Hi. The brief that we have for this morning's session is to discuss how we can sense and make sense of real-world data to inform and to drive our buildings. Equipped with different technological means and devices, how do we cope with the vast quantity of unstructured input, determine which data are to be captured, and which are the different ways that they inform, alter, and enhance the design? What mode of inhabitation of structures of the future? What is the mode of inhabitation of structures of the future? What are the software, hardware, and theories and concepts that drive the infiltration of information in design and construction? And to that, I'd like to ask, and occupation, because I think it's, to add and occupation, because it's, I think, really important that we really believe that we're working with a real-time medium in architecture rather than creating a set of static objects. I'd like to suggest that the architectures that we design might be dumb, and that smartness might reside in the things that we put into them and onto them. These things might adapt in real time to the people that inhabit our architecture and the world that surrounds it, a world of data of increasing sophistication and complexity. Now, if I could ask the panel members to come up to the, onto the rostrum, I think that would be quite good. The speakers we've got are Theo Spyropoulos, who's the director of the Architectural Association's DRL and directs experimental architecture and the Design Studio Masters. This is Theo. I'm sure you all know Theo. Usman Haq is an architect, an artist, a director of Haq Design and Research, the founder of Pachu, now known as COSM, and a former CEO of Connected Environments. Abdul Majid Karnouth is an associate director, an associate architect, lead consultant, and design innovation research at ADAS, with a special focus on facade engineering. And I'm sure you all know his really beautiful origami facade in Abu Dhabi. And our panelists are Flora Salim, who holds a PhD in computer science and is a postdoctoral research associate at the Information Architecture Laboratory at RMIT, and is a long-time contributor to Smartgeometry. And Christina Dumpiotti is a PhD fellow at the RCA, a lecturer at the Architectural Association, a member of the Ocean Research Network, and part of the Smart Geometry Planning Committee. So I think what I'd like initially to ask is Theo to begin his presentation, and we'll all sit and be interested. Here.
Okay, can you guys hear me with this microphone? Thank you very much, Stephen, for the introduction and for the organizers for allowing me to participate. This is the first time that I've been involved in some capacity to share some of the work that we've been developing within this context, so I hope that the contribution will help facilitate some conversation, I guess, within the context of constructing data. Most of my ongoings and research have really been situated within a certain context of generative design and behavioral design. What I kind of want to situate today as a kind of provocation for some conversation is the notion of how one can sort of facilitate a new understanding of architecture, primarily within the idea that architecture resides within a certain context of knowledge, and that design in itself is a certain mode of inquiry that resides somewhere between the material, computational, and digital. A lot of the influences that situate the work that we are developing at the AA, at the Design Research Lab, and with my brother within Minima Forms really facilitates a certain kind of belief in the challenges that experimentation and research in itself actually has within the context of architecture. We believe architecture in itself is a framework, and its pursuit is really for novel material and social forms of systemic interaction. One of the things that we really believe architecture fundamentally at the heart of it is really to try to facilitate new forms of communication between human agency and non-human agency. I give some examples of some of these constructs of today, or frameworks, of where we start to see a kind of greater synthesis of what we call data today. This is Google developing a strategy for an autonomous car, just to give you an idea.
Oh my goodness. Go is the right word. Holy shit. Holy shit. There's no fucking hands on that wheel. Oh my god. What?
It's driving itself.
One of the things that I think is quite important to sort of understand is that the nature of where research actually is right now is really in a much more operational state of thinking about where design, research, systems can actually be integrated. And to think that this sort of resides solely within the framework of Google or these kind of companies is a kind of misunderstand a certain kind of interest today of much larger synthesis. So every automobile company is rethinking the concept of mobility, how systems can be interacting with each other, data share, a new construct of a concept of real time that is enabled. So for example, the notion of what we're talking about is something that is beyond geometry and is actually doing something radically different today, which is really trying to look at how information systems can proactively sort of engage beyond communication, beyond virtuality, into sort of really being able to negotiate and enable a different understanding of space, context, and time. So for example, the Google car, like many other autonomous systems, is really trying to network local agency, local response systems and sensing with much more far-reaching global networks, and in a way trying to develop a certain kind of attitude towards learning, which we think is kind of fundamental when one looks at the issue of data. Residing within computation and architecture, I believe in systemic forms of interaction, but one of the things that computation itself is a very generic word. So the issue of generative approaches, behavioral approaches, parametric and analog, or let's say material computation, I think plays a very important role. And part of that is also having a greater understanding that this project isn't a project of today solely, but it's been one of an evolving legacy. I would argue from the 50s till today, really trying to see a much larger synthesis between the sciences, the social sciences, between chemistry, biology, between architecture and design disciplines, between computation. For example, Claude Shannon and his sort of pursuit of sort of designing a system of a maze and pathfinding mouse that had the capacity to learn, mechanical systems that were enabled with a certain kind of intelligence, like Stephen said, that were simple or possibly even dumb, but have the logic of memory and evolution. Today we talk about machine learning and decision making, and part of that is constructing a new idea of search space and performance. Even our vacuum cleaners like Roombas and so forth have to construct a way to operate in the world, and these are two suggestions of two different companies that basically are trying to design a way to better clean your house. When we talk about these things, a lot of the notions of code itself start to change with the challenges of what it means to develop systems that have the capacity to learn. So for example, machine learning and this very simple algorithm, which is called the infinite monkey theorem, is to play through trial and iteration and construct very particular task-dependent features that would allow the code to be able to evaluate itself within a certain kind of evaluation, which was generating the image of Mona Lisa. This is a different version. This is basically how to play Super Mario Brothers better, but a certain way of mapping a system dynamically and in a way allowing the algorithms to better perform through iteration and through sort of evolution. So these words in architecture have had a radically different meaning, and possibly one of the challenges for us today, and very much for, I think, the community that everybody is talking about, is to sort of situate how our time is slightly different from sort of seminal figures from Negroponte, John Fraser, and others who were working on a similar subject, who were arguing for evolution, computation, and so forth. I think it's really important to understand that a lot of these technologies had a heart and a placement within architectural research. So the Architectural Machine Group, that was an initiative that originally was looking at CAD systems in intelligent environments. After, let's say, a 10 or so year experiment, transformed into something or was renamed the Media Lab at MIT. But the questions, I think, are fundamentally important for us because as we've witnessed that communication technologies radically revolutionized things over the last 30, 40 years, we also see that there is an importance of reintroducing the notion of space, architecture, the physicality and the communication between objects and so forth, and in particularly the reconsideration of what the role of the architect is today. For us, anyway, the challenges are really interesting to look at models that are possibly more participatory, that engage human engagement, models that have a legacy within cybernetics and other kind of disciplines that sort of dissolved into a lot of things within systems theory, AI, and other aspects, I think are important to question and to explore. Those kind of early robotic experiments can be seen today in other research institutes, for example, at ETH, where Raffaello Di Andrea is working with simple kind of quadrocopters, but actually evolving a certain intelligence where humans can participate with the quadrocopters, but actually they don't need us. They can participate and play with each other. The reason that I think a lot of these things is very important to sort of situate is because also it's important to understand that these questions have sort of transformed over time. In the 90s, Carl Sims was developing a very particular kind of idea of developing systems that would evolve, create fitness criteria, create new ideas of body plans through genetics and digital algorithmic processes. So for example, these were evolving creatures that he was developing, primarily looking at gaming systems and so forth that he was developing it for. But in terms of the radicality of the project, I think have very important kind of resonance with a lot of the things that we're doing today. To think about that as a 90s virtual project that resided primarily within digital design is to also look at more contemporary resources of things like Boston Dynamics that are developing agent-based robotics. Of course, in this case, it's for the military. I'm not suggesting that, but in a sense, developing kind of systems that have their own capacity to self-regulate, to perform, to engage with the world, and to have lifelike characteristics that are driven by a certain form of operational research. The big dog itself is a robot that has an amazing response. It's different from the kind of early robotics in a sense that it's sort of developing a very kind of reactive model and understanding of its own sort of, let's say, body plan in terms of how it responds to itself, its environment, and to stimulus, in this case, being kicked by one of its creators. Within the Design Research Lab, we look at different kinds of systems, and I think like we don't privilege a particular kind of mode of inquiry, but we find that there are a lot of models that obviously offer us a certain kind of understanding within genetic systems. Some of them reside within natural models, some of them are synthetic, termite ecologies that could deal with certain stigmergy logics, that could give us a certain understanding of depositional strategies, playing on the issues of self-assembly or deposition, other things that are actually trying to evolve a certain concept of smartness, but that resides in a kind of idea of how bricks could possibly engage itself, self-assemble, be able to construct a kind of understanding of population-based logics. In this case, it's a research that a group of my students were developing to reconsider the aggregate for a space station that would be deployed as a kind of self-assembling kind of space-making device that had the capacity to collect space junk and create kind of particular environments. So the notion of packing, the idea of deployment, all of these different things actually deliver radical different criteria in terms of understanding how we work actually on the project. So the issue of actually developing certain logistics is beyond, let's say, the idea of science fiction today. We are sort of operating in a world where the radicality of the real or the everyday is way beyond, let's say, the initial concepts of things that were operating in the 60s and 70s that were sort of arguing for a kind of idea of the future. The future is now. It's basically been enabled by a series of different technologies that are really, in a first time, I would imagine, at this level, shared and collective and being worked on by really an audience and a community that obviously are participating and are enabling a certain kind of idea that goes beyond simulation and goes beyond particular ideas of defining the world. They're basically also giving us opportunities to also rethink and look at some of those early analog and computational experiments, but also some of the material experiments like Frey-Otto and others where students are actually dynamically looking at the coupling of particular minimal surface logics coupled with agent logics and developing a kind of interactive idea of how these things could actually have certain performative features that are time-based and evolving. So for the conversation today, the things that I want to sort of champion a bit is the notion of interaction, intelligence, and experience. These things don't necessarily reside solely within the human discourse and human exchanges. They are also driven by material behaviors and performances. There are rules and constraints that basically govern everything, and in a certain way, computation allows us a certain access of that. There are properties of materials that allow us to think about new ways of considering not materials in terms of an inert kind of capacity, but things that are dynamic, lifelike, phase-changing, reactive. And in a way, simple experiments, even playing around with phase-change materials and things like that, offer a radical challenge for how the role of simulation actually has to evolve. Instead of trying to map the world, is actually trying to participate and collaborate with different kinds of systems. In particular, the ones that we're interested in are material systems, a way of rethinking some of these seminal examples that basically litter all of our kind of research, like Frey-Otto's detour networks, and to see what time-based systems actually really inform us, where the resolution, the idea of dynamic stability is something that we can discover by understanding not a fixed position or a fixed state of something, but something that is actually residing within strife and conflict, and in a way is a moment in time. I don't know how my time is, actually, that being said. But the only thing that I kind of want to argue is that making fundamentally for architects is actually a very big part of actually how we can think through computation. It's really to shift from modes of representation into ideas of the prototypical and to engage systems in a way that actually also looks for the anomalies of what it means to actually deal with computation. These are experiments of basically hacking our CNC machine and using it as a deposition system within our laboratory, dealing with phase change materials that have the ability to transform, and in this case it's sodium acetate, dealing with simple systems now with Arduino-based kind of controls and the idea of microcontrolling that would allow discrete sort of elements to be able to communicate with each other through light or through sound or through other sort of mechanisms that are very common. Developing robotics within an architectural discourse that doesn't necessarily mean that we are technicians of robotics or that we are computer scientists, but we are trying to sort of actively participate in learning how we can look at these things, work on the projects because they sort of inform a certain kind of knowledge of, and work beyond a certain kind of assumption about how these systems work. One of the things that I think is important that the challenges of architecture still remain. It's not a technocratic kind of issue. For example, on the left-hand side, you have Thomas Edison, who was developing a strategy for basically constructing a house in a day. We're talking about 1890s, we're talking about concrete casting for the idea of generating the idea of a house. On the right is examples of some of our students that are developing soft cast, textile-based casting systems. That challenge hasn't really changed very much. But when we look at the discourses of today, even things like Koshnevitz and other people that are working about the idea of 3D printing buildings and so forth, we see that the challenges of what it is that we're doing really are sort of undermined with the heightening of a certain kind of idea of the tools that we're using and the methods. So for example, the house here for Krishnevitz is still a house in a very traditional sense. The idea of living or those other kind of contextual features are not necessarily brought to bear. So I think it's important to situate ourselves and to reside to possibly some of those early experiments and thought experiments of people in the 60s and 70s, which resonate a lot with me, particularly because they didn't have access to computers, and they tried to set up certain problems that were beyond the actual technical aspects of what it is that they were doing, and more why they were doing it and for whom. So for example, people like Cedric Price, John Fraser here, Gordon Pask, people like Stephen and others, Alan, all definitely been working on a project that I think has continued and has been enabled today in ways that really, I think, resonate with us probably in better ways than most. But for example, even at the AA, I thought this title of a continuing experiment, I think, is something that is an important thing that I hope I can share for the conversation, which is to basically suggest that this is an evolving discourse, this is an evolving period, but we have to sort of situate the radicality of the accessibility that we have today. I think those challenges are shared, they're collective, and if they are engaged, we can radically think or rethink the role of the architect, the idea of participating in things that are not necessarily driven by disciplinary boundaries, which are kind of superficial or specialist in a certain way, but really larger challenges of the everyday that I think are residing in a lot of the things that we're sort of engaged with. So with that, I thank you for the time, and I look forward to the conversation.